12 and 13, final two from the practice test. So these are tricky, right? You should always look at it and think about what is it saying first. If I think about this, it's saying that x minus 5 is 7 or more from 0. So if I took this statement here and I demonstrated it with the graph, right, 7 or more from 0 would be either exactly 7 away to the right, because all those numbers are 7 or more, but also negative 7 is exactly 7 from 0. So I shade that in because it can equal it. And to the left would be further than 7 from 0. So my x minus 5 is somewhere in there or somewhere in there. I already see as well that this is an or statement. If this was going the other way, if it was less than or equal to or less than, it would be an and statement. All right, so setting this up, this is saying that x minus 5 over here is saying it is less than or equal to negative 7. Or, right, because this is an or statement, two different directions, x minus 5 is also, or it is greater than or equal to 7. So we just solve these two independently, as we do with any component inequality or statement, be it x is less than or equal to negative 2, or x is greater than or equal to 12. All right, so graphing that, a simple graph here. That's 0 and that's negative 2. Say 12 is somewhere over here. So greater than or equal to 12, closed circle to the right. Less than or equal to negative 2 would be a closed circle to the left, like this. So here's your answer, here's your graph for this one. So you got to make sure on the test you look and you see, what is this saying? I like to put the graph so I can really see visually what it's saying and see where my x minus 5, in this case, can be. 13 is graphing a linear inequality. So for this one, we can see it is in slope-intercept form. All right, so we can see the m is 2 over 3. Our b is negative 5, which we talked about. This is a point. It's the point 0, negative 5. So the next thing is to look at the inequality sign. In this case, it is greater than or equal to. Because it has the or equal to, it's going to be a solid line. But if it did not have that, if it was greater than or less than, we know it's a dotted line because that line is not within the solution set. It's not, those points are not part of the answer. So let's graph this. This is y-axis, x-axis. All right, so we start from this point, 0, negative 5, which is 1, 2, 3, 4, 5, right here. And our slope, 2 over 3, means that we're going up 2, right 3, right? So rise over run. Top number is always up or down, bottom number left or right. So from this point, we go up 2, 1, 2, right 3, 1, 2, 3. You can do that as many times as you want. So to here. Okay, we already know it's a solid line. So it's going to look like this. The line is kind of curvy, it's fine. Now we just need to determine which side do we shade. So I like to test 0, 0 to see if that is an answer on this inequality. So if I plug that into my inequality here, I get, sorry, this is the x value, the y value of the point. So I get y 0 greater than or equal to 2/3 times 0 minus 5. That makes 0. And 0 minus 5 is negative 5. This is true. Right, 0 is greater than negative 5. So that means 0, 0 is an answer, and everything on this side is also an answer, so we shade the side that contains 0, 0. So everything on this side of the line would make this statement true if you plug that point, any of these points in. So there you go.